Okay, so today we're going to look at division of rational expressions. When we're dividing rational expressions, just remember that if you are dividing a regular fraction, such as 7 over 10 divided by 3 over 14, the way we approach problems like this is we turn into a multiplication problem. And in doing so, you're going to end up flipping this, and we are going to end up with well, actually, before we even do that, now we can simplify it. So we have 10 on the bottom and 14 on the top. And so if I think about 2 goes into 10 5 times and goes into 7 or 14 7 times. I'm going to be left with 49 over 15. All right? And so remember, when we are dividing by a fraction, then we're actually going to be multiplying by its reciprocal, or 14/3. So when we approach these types of questions, such as class example B, sorry about the camera there, we're going to do the exact same thing. And so this is going to become 16a over 9b squared, and then we're going to multiply that by 15b if I flip this, and the top and bottoms trade places. Okay? Now, this is where multiplying rational expressions is sometimes a lot simpler than adding and subtracting, because from here we can cancel out what's on the top and the bottom. So if I have an a here, there's one a here and 2 on the bottom, so that's just going to leave me with 1a. And with my b's, there's 1 on the top and again 1 on the bottom, so I'm going to be left with 1b on the bottom. And then I look at my coefficients and try to pull out the common factors. So in this case, I know that 16 goes into 16 once, it goes into 32 2 times. And if I look for my 3's, 9 and 15, 3 goes into that 3 times and goes into this 5 times. And I'm going to be left with 5 over 3 times 2 is 6, a and b, 6ab. Okay, so we just want to simplify, and at this stage we do not want to state the restrictions on our variables. Okay, so that's how you approach these problems here. With this next one, you would approach it the exact same way. You'll cancel out your variables, and on this is going to switch places, so we're going to have negative 21 on z4 on the top and 10x squared y squared on the bottom. All right, I'm not going to do that one. I'll let you guys tackle that. But let's look at what our non-permissible values in division rational expressions would be. So consider the division a over b divided by c over d, where a, b, c, and d are variables. For the rational expression a and b, the non-permissible value is that b can't equal 0. For the rational expression cd, the non-permissible value is d can't equal 0, right? Because we'd be dividing by 0 in that case. So the first step in simplifying AB over or divided by CD is to invert the divisor and multiply it to obtain A over B, and all we did to get times D over C is we flipped this one over the bottom. So then this introduces one more non-permissible value, and that's C can't equal 0. All right, and so we ended up having 3 non-permissible values in that case. And so in the above question, if we look at the next page over here, for a division of the type A over B divided by C over D, we had to consider all 3 of those values as non-permissible values. So this is the question that we solved earlier. All right, and we're just stating the non-permissible values, but in that question we ended up flipping this, remember? And we were left with A on the bottom, and we had A and B on the bottom for our final answer. Our final answer ended up being 6 over, or 5, ended up being 5 over 6 AB previously. So I see I do have a and b as my non-permissible values here. A can't equal 0, and b can't equal 0. All right. Now let's look at, I didn't actually solve this one previously, but I will solve it now. So if I have negative 5x cubed times 2z 15x, let's rewrite this as our equation x z and z cubed times 2z over 15x multiplied by, because I'm going to switch this over, negative 21z squared over 10x squared y squared. Now from here I can cancel out some of my common multiples. So negative 5, if I cancel that negative 5 out, then I know that 5 goes in that once, goes into 15 3 times. I know that 3 goes into 3 once and goes into 21 7 times. I know that 7 and 7 are going to cancel each other out, leaving me with 1. What else do I have here? I know that 2 goes into 2 once and goes into 10 5 times. And so I know for my final answer, I'll be left with 5 on the bottom because there's no more coefficients. If I have an x here and an x here, those can cancel out. And then I'll be left with, let's see here, x and x. I have z squares still, and so one of these z squareds can cancel out one of these ones, leaving me with 1z on the bottom, but then I have one more z, canceling out all my z's. Next thing I have is a y cubed and a y squared. And so y squared, I'll get rid of that and get rid of one of those y cubes, or two of those y cubes. And so I'll be left with y and no more z's, no more, I have 1x, 2x, 5x cubed. And that would be my final answer, but my restrictions are going to be, I have x, y, and z. So x can equal 0, z can equal 0, and since I flipped that, y also cannot equal 0. So all three of those are going to be my restrictions on that value. Now let's look at one of these questions. State the restrictions on the variable. All right, so approaching this question, x plus 1, x minus 2, x plus 3. Remember, we need to flip this, and so we're going to be left with x times x plus 3 over 2 times x plus 1. All right, now what we can do is we can cancel out our common factors. So I have x plus 3 and x plus 3 here. I have x plus 1 and x plus 1. And I'm only left with x right here. And so my final answer is going to be x over 2x minus 2, or x minus 2 times 2. And we're saying our restrictions are that x cannot equal, we had negative 3 to begin with right here. Negative 3, I had negative 1, I have 0. In my original equation, we had 0. And I also have 2. So all four of these are restrictions that x cannot be equal to. Okay, now let's look at this next question. 4x plus 12 over 3x plus 12 over 3x squared plus 9x over x plus 4 squared. Now, if you're looking at this and this seems kind of daunting, remember that we have, all this assumes that we have 4x plus 12 over 3x plus 12, and that's being divided by 3x squared plus 9x over x plus 4, and that's squared. Okay, And so if we approach it that way, it'll be a lot less daunting. Now let's approach this question how we usually do, by making it a multiplication. 4x plus 12 divided by 3x plus 12, and then we're going to multiply it, in this case, multiplied by x plus 4 squared divided by 3x squared plus 9x. Now what we want to do here is factor out the terms that we can factor. So 4x plus 12, we can factor out 4x plus 3, and that's going to be, and we can factor the 3 out of here, and that'll be x plus 4. And we're going to multiply that by x plus 4 squared is x plus 4 times x plus 4. And that's all going to be over, if I bring the 3x out of that term, 3x, x plus 3. Okay, so from here we can cancel out some of our coefficients, or some of our terms. So x plus 3 and x plus 3, x plus 4, and one of these x plus 4s. And so what I'm going to be left with is 4 times x plus 4 over 3 times 3x is going to be 9x. And we say our restrictions, x cannot equal, well, we had 4 and 3 in our original equations, so that's negative 4 and negative 3 and 0. So those are all our restrictions on this particular question. Now looking at question class example 5, I'm going to do the more difficult one, so I'll do this one on this side here. Okay, so if I want to perform the indicated operations, so this operation, and this operation, and then I want to express my answer in lowest terms and identify the non-permissible values. Okay, so let's do it. First thing I want to do is I want to start by factoring all my equations here, all my expressions. Okay, so make sure you leave yourself some room for this question. But if I'm beginning by factoring, then if I'm looking at 20m squared plus 30m, I can factor 10m out of that equation. So that's going to be 10m times 2m plus 3. 2m plus 3, that's what I'm left with on the top. On the bottom, if I factor 9 minus 4m squared, that's a difference of squares, so that's going to give me 3 minus 2m, 3 plus 2m. Alright, next thing we need to do is we're dividing this side. Now I'm going to leave it as a division question, and then at the end I'm going to flip it. Okay, so if I'm doing the same thing I did on this side, I'm going to begin by factoring it. So I'll bring out 11m. So 11m is going to give me m squared minus 1. And if you look at that, yes, we have a difference of squares. And then on the bottom here, we are going to be left with, you could decompose this, but you might also be able to do it by looking at 2m minus 3 m plus 1. And then we're going to multiply that by, we can't really factor that, so that's going to be 2m plus 3 m minus 1. Okay, so from here, before I even multiply it, I'm gonna simplify this side. Alright? And one of the reasons I'm doing this is because if we follow our order of operations, BEDMAS, then, or PEMDAS, you know what you have to deal with the numbers in parentheses or brackets first. Okay, so let's deal with those numbers before we even begin. So we're going to be left with 11m, m minus 1, m plus 1, because this is a difference of squares, over 2m minus 3, m plus 1. And by now you might be looking at this and saying, oh, there's going to be a lot of numbers here canceling out. 2 plus 3 over m minus 1. So let's deal with these numbers that we can actually cancel out. I have m minus 1 and m minus 1 and m plus 1 and m plus 1. And those terms are going to cancel out right away. Now I can deal with what I have here. So I have 10m, and actually over here too I can get rid of my terms that are canceling out on the top and bottom on this side before I actually move on. So I'm just going to be left with 10m over 3 minus 2m here. Get rid of that. That's why you don't do math in pen. And then I'm going to multiply what I had over here. And so I was left with 11m times 2m plus 3. And so since it's on the top here, when I multiply it, it's going to go on the bottom now. So I'm going to have 11m times 2m plus 3. And what was on the bottom goes to the top, and that will be 2m minus 3. Okay, now if I were to organize this term, remember, if I flip this around, if I divide this by -1, that's going to leave me with 2m minus 3, like what I have up here. But then I'll have a -1 that's left over. Okay, so I can do that, leaving that -1 behind, which would make this whole thing -1. And then I can just multiply across, since that is 1. That will be left with 10m, subtract, and this is negative, do this -1. So not subtract, divided by 11m, 2m plus 3. And that is our equation. And from here, what we need to do is, we can actually cancel out these m's too. So I'm with -10 over 11, 2m plus 3, and I can state my my non-permissible values. And that's going to be m cannot equal, and now this is where we have to look at what we originally had. Okay, so we know we had a 1 in there, and we also had a -1 and a +1. So m can't equal plus or minus 1. M can't equal 3 over 2 plus or minus 3 over 2, because we had the plus here and then we have a minus here. M can't equal the last one over here. We had M can't equal 0 at any time. Alright, so big questions that you have to keep, keep track of the numbers that you're beginning with and the numbers that you're ending with, and how those are all going to contribute to your non-permissible values. Now, let's look at this last question. Simplify the following and state the restrictions on the value of A. Okay, so with a question like this, the first place I would start with is just by thinking about, or even rewriting, how you want to approach this question. Okay, so one thing you can do is you can rewrite it as 10a minus 12 divided by 2a plus 1, and then divided by 5a plus 4. But one thing you might want to do is, even before you do that, is simply just simplifying all your expressions. Okay, so let's start with the top part. We're going to have 10a minus 12 over 2a plus 1. If I find a common denominator, because we have to, because it's a subtraction and an addition question, we'll have to find the lowest common denominator for the top and bottom. So in the case of the above expression, the lowest common denominator is going to be a 2a plus 1. And on the bottom, since this is over 1, 4 over 1, that's just the lowest common denominator is going to be a. So using these as our lowest common denominators, we now know what we have to multiply 10 and 12 by in order to get this lowest common denominator. So 10 times 2a plus 1 minus 12 times a over a 2a plus 1. And remember, we had to divide this expression by the bottom. And so if we do that, we're going to be left with 5. In order to get a, I just multiplied 5 by 1. 5 plus 4, I had to multiply by a to leave me with that over a. Now the next thing we need to do is we need to simplify. So 10 times 2a plus 1 is going to leave us with 20a plus 10 minus 12a over, and we don't simplify the bottom, so that's just 2a plus 1, a times 2a plus 1. But on the top, or sorry, on the next expression, 5 plus 4a, we can't really do anything there, so we're going to leave it like that. So now what we want to do is gather our like terms, and we're going to be left with 8a plus 10 over a times 2a plus 1, and that is all over 5 plus 4a over a. Now from here is where I would kind of switch this equation, because I know that this is equal to 8a plus 10 divided by a times 2a plus 1 divided by 5 plus 4a over a. So remember, if I multiply this and switch it around, I'm going to be left with 8a plus 10 divided by a 2a plus 1, and I'm going to multiply that now by this expression that I flip over, a times 5 plus 4a. Now this is an expression, this 8a plus 10 is one I can factor, and once I factor that, I'm going to be left with, if I bring a 2 out of there, I'll be left with 2 times 4a plus 5 over a 2a plus 1 times a over 5 plus 4a. 5 plus 4a and 4a plus 5, those are actually equivalent terms, and so I can get rid of those, cancel that out. My a's are going to cancel out as well, and I'm going to be left with 2 over 2a plus 1, and my non-permissible values are going to be a cannot equal negative 1/2 from here, also cannot equal 0, or negative 5/4. Okay, non-permissible values, and this is my simplified answer.